Hello and welcome to the 15th video in this series introducing neural networks. So this video then we're going to write the code that actually does the population evolution rather than just creating new generations of random stuff here. To do this, one of the key things we need to be able to do is actually generate an offspring. So when we have two parents, we want to generate a child, and we're going to do that by putting a static function or a class function into our bird class. Before we do that, there are a couple of imports I want to add to the top of the bird class. Well, there's one, and that's just importing numpy because we're going to be using it. And then right at the bottom of the bird class, so after the get inputs, we can start writing our new function to create an offspring from two parent birds. So we create ourselves a new bird with the game display, and now that bird of course has a neural net, and we'll use then the create mixed weights function that we've written in our neural net to create some mixed weights in this neural net from this new bird from P1 and P2, which are both of the parents. And now we've done this, we can return our newly created bird. So that's all we need to do using a neural network then to create a child that's a mix of the two parents. And now the rest of the code we need to write is inside this evolve population here. So first things first, let's get rid of the printing of the fitness. We've got the birds sorted, and we need to add, I've just realized, 3 definitions into defs.h. So just down the bottom here, I'll add those in. We have a mutation cutoff, bad to keep, that's a percentage of bad that we'll keep, and the chance that we're going to make a modification, and you'll see how these are used inside the code. So the first thing we want to know is the cutoff. So we want to know how many of the good birds we actually want to keep. So cutoff will now have the number that we actually want to keep, and if I can spell mutation correctly. And now we can store a good birds list of the amount that we want to keep. And that means we can also create the list of our bad birds, which is the other birds. And now what we want to know is we want to know how many of the bad birds we actually want to keep, because we said, if you remember when we went through the mutation video, that we're also going to keep a selection of these bad birds. And before we go any further, what I'd like to do is just modify the weights of all of our bad birds a little bit so we get some kind of variation. They were bad, but we still want to maybe keep something, but we'll put a little bit of random modification in there of all of the bad birds. And now I want to select which of the bad birds I'd actually like to keep and start adding them to a list. So we'll create now our final list, and we'll call this new birds. This is the new population that we're actually going to create. The first thing that we'll do is add this number of numbad to take, this selection randomly picked from our bad birds. Now remember, to get random indexes we use np, so numpy.random.choice. So here I'm saying for the amount that we want numbad to take of the full list of bad birds, get ourselves some random indexes, and then we can take those birds. So I'll say for index. And the first thing we've done to our new generation is actually add some randomly modified and randomly selected bad birds. What we can now do though is add the good birds that we wanted to keep as well. And now we need to know how many children we still need to add to complete our population to get it up to the original size. So that'll be the length of our existing population minus the current amount that we've got. We'll say how many children we need. And then we simply need to make a loop to evolve and create children. So we'll say that whilst the length of our new birds is less than the length of self birds, we want to now select randomly 2 parents to be able to create a child. And we'll select those randomly from our good birds. So I'm saying here, give me 2 random indexes from the amount of good birds that we have. Those indexes should be unique, but just in case, I've put an if the index to breed 1 is not equal to index 2, because I don't want to breed the same thing with the same thing. We can make ourselves a new bird by creating an offspring. So that then gets us using the create offspring, a new bird, which is created from mixing randomly the weights of the two parents. And the last thing now is, do we want to add a little bit of randomness into this child as well? So we'll say that if random.random is less than mutation modify chance limit, then we'll modify the weights a little bit of this bird. And last but not least, we can now add this new bird to our new generation. And that's all we need to do. So we've created, just to go back, we've kept a selection of good birds. They've been added to our new birds list here. We've randomly selected some of the bad birds and randomly modified some of the weights and added those as well. We've seen how many children we need. Then we've selected from the good birds random parents, created a child each time, and then with a small chance also modified some of the weights there, so that we're continually adding new stuff in and appended that then to the list. The last thing we need to do is just reset all of these new birds and then set our current collection now to these new birds. And that should have the effect that each time we call evolve population, we get a new and better at flying and surviving population to play the game, and that should be us in the state to be able to watch it learn. So let's run this in the console and see how many spelling mistakes I've made and see if it works. So I've let this run now for a few iterations. It's actually had an alarmingly good start compared to with what I've sometimes experienced on iteration 6, and it's already playing the game pretty well. You'll probably have something different depending on the random numbers and things, but hopefully that's given you an insight, these last few videos, into how fun it is, really, how much fun it is. And although it's not simple at first to grasp the concepts what you have, you can see that they're very, very powerful, and you can start, well, I do certainly, thinking of lots and lots of different projects and applications for this, and I really do find it fun to do and very interesting to watch something learn like this. So I hope you enjoyed this series. I hope it's really helped you with the introduction. Comments and questions are welcome, criticisms obviously as well, for how to improve. If people like this series, I might do a couple more. I've done another couple of projects on learning with random forests and decision trees and things like that, and it's all very interesting and really every time really astonishing just how good and how quick these things can work. So that's signing off from the end of this series. Hope you enjoyed it, and see you in another one. Thanks for taking the time, and thanks for watching.